our last software is Matlab. So Matlab also solves linear programming problems, and it has a special command called limprog. And it has 7 inputs. So let's define these 7 inputs for our problem. Now F stands for the objective function. So we enter the objective function coefficients as f. But the thing is, the limprog command solves minimization problems. So we have to convert every problem to a minimization problem. And when we take the negative of this function like this, our problem is turned into a minimization problem. So what we do is we define f first, objective function coefficients, minus 20,000, minus 15,000, and minus 16,000. So these are our objective function coefficients. And the next thing is a here. A is the constraint coefficients of less than or equal to constraints. So we have 3 less than equal to constraints, and our A will be a matrix of 3 variables and 3 constraints. Each row will have the constraint coefficients for one constraint. So let's define it. A is the constraint coefficients of less than or equal to constraints. So the first constraint has the coefficients of 50, 30, 30. This is the first row. First row has the coefficients of the first constraint. Now the second row will have the coefficients of the second constraint, which is 2, 3, 2. And the third row will have the third constraints, 1, 1, 1. So, as you can see, these are our left-hand side constraint coefficients of less than or equal to constraints. And the next thing, B is the right-hand side of the less than or equal to constraints. So you can write it as a row vector or a column vector. Actually, it doesn't make a difference. So my right-hand sides are 2000, 70, and 30. So B is 2000, 70, and 30. So these are my right-hand side. I have the objective function, left-hand side coefficients of less than or equal to constraints, and right-hand sides of the less than or equal to constraints. Next thing we have AEQ is the left-hand side constraint coefficients of equality constraints. But right now I don't have any equality constraints. So, but I have to enter something here. It's there as an input. So what I do is I create an empty matrix and state that it's the left-hand side of my equality constraints. And next we have BEQ here. As you can expect, it's the right-hand sides of the equality constraints. And since we don't have any, I assign it as an empty matrix too. Now, Lindot by default assumed that all variables were non-negative, but Matlab doesn't do that. For Matlab, the default value is infinity. So all variables start from minus infinity and go to plus infinity. So the next thing we have is the lower bounds LB is the lower bounds for variables. Now, all my variables start from 0. All my variables are non-negative, so I have 3 variables. So I enter a vector of zeros. This is for x1, this is for x2, and this is for x3. But I don't have an upper bound defined, so the upper bound is an empty matrix again. Sorry, an empty vector again. Now I will get two outputs, sorry. The first output is x, the value of my decision variables, and the second output is z, which is the objective function value. And I solve it using limproc, f, a, b, aeq, beq, lower bound and upper bound. Solving this, you get 30, 0, 0. This is for x1, x2, and x3. And now the thing is, we converted our maximization problem to a minimization problem by multiplying it by -1. So we get an objective function value of minus 600,000. So we have to multiply it by -1 again to get our actual value. You don't need to do that actually, but still. So this is our objective function value. So that's all for Matlab. Of course, you might ask, we covered less than or equal to constraints and equality constraints. What about greater than or equal to constraints? Actually, you can turn them into less than or equal to constraints. Let's say that this constraint is greater than or equal to constraint. Then multiplying it by -1, you get the same constraint in a less than or equal to way. So what you do is you get the last row of constraints of -1, -1, -1, and the right-hand side of -30. So that's how you deal with greater than or equal to constraints, which we don't have any for this problem.